The rover, called Perseverance, survived a perilous high-speed plunge through the Martian atmosphere and made it safely onto the surface of the red planet.
When NASA sent the Spirit Rover to Mars in 2004, it was supposed to be a short mission. Just 90 sols, a little over 3 months to study the red planet's surface. But Spirit went above and beyond expectations, operating for over 6 years and covering more than 4.8 miles of Martian terrain. Along the way, it overcame dust storms, frigid nights, and countless technical challenges, all while collecting invaluable data that transformed our understanding of Mars. As its mission drew to a close, Spirit stumbled upon something extraordinary. On what turned out to be one of its final excursions, it uncovered evidence that left researchers both thrilled and uneasy. Hidden beneath a seemingly ordinary layer of Martian soil was proof that this wasn't just another rock. It could be the key to life beyond Earth. But understanding this strange discovery isn't so simple, nor is it the first one that has had an impact like this. The Spirit Rover's mission. Why it began. NASA's Spirit Rover was launched on June 10, 2003, as part of the ambitious Mars Exploration Rover program. The mission had a bold objective: to determine whether Mars was ever a habitable planet capable of sustaining microbial life. Scientists were particularly interested in the planet's surface features, the ancient river channels, dry lake beds, and mineral formations, all of which suggested the presence of water in Mars' distant past. If Mars once had water, it might have had the conditions necessary for life to develop. To answer these questions, Spirit was equipped with advanced scientific instruments, enabling it to investigate the planet's geology and climate history. The miniature thermal emission spectrometer allowed Spirit to detect minerals formed in water, while the alpha particle X-ray spectrometer and Mossbauer spectrometer analyzed soil and rock composition. Additionally, the rock abrasion tool was designed to grind into rocks, exposing unweathered surfaces for more precise study. The rover also carried panoramic and microscopic imaging tools to capture highly detailed visuals of the Martian landscape. While all of that works on paper, could Spirit really deliver it all in real life? That was a question on everyone's minds. The journey to Mars. Spirit's journey began atop a Delta II rocket that launched from Cape Canaveral, Florida. Its 7-month trek through space required careful planning and engineering precision to ensure it arrived safely at its target destination, Gusev Crater, a vast basin that scientists believed once held a massive lake. Gusev Crater was chosen because sedimentary deposits there could offer evidence of Mars's wetter past, so it wouldn't have to venture out too much and set to collecting samples immediately. On January 4, 2004, Spirit touched down on Mars and began a dangerous descent. The rover entered the Martian atmosphere traveling at 12,000 mph. To survive the landing, it relied on a heat shield, parachutes, and an innovative airbag system that cushioned the final impact. After bouncing several times across the rocky surface, the rover came to a rest and successfully unfolded its solar panels. Spirit's first images were transmitted back to Earth shortly after touchdown. It gave us a first look into the barren terrain covered in reddish dust and scattered rocks. This was officially the beginning of Spirit's detailed exploration of Gusev Crater. Its immediate tasks included assessing its surroundings and conducting geological surveys of the crater's floor, which was blanketed with volcanic material. Scientists soon realized that Gusev Crater was more geologically complex than initially thought. There was a lot of work to do, and it got right to it. Climbing Husband Hill. Spirit's ascent of Husband Hill, a towering feature in the Columbia Hills Range, marked one of the rover's most ambitious endeavors. The climb wasn't just a technical challenge. It also represented an opportunity to unlock new geological secrets. Towering over 350 feet above the surrounding terrain, Husband Hill offered a unique vantage point to study Mars's environmental history and gave scientists the chance to examine rocks and minerals exposed by erosion. Progress was slow and painstaking. The terrain was steep and riddled with loose, rocky surfaces that pushed the rover's driving capabilities to the limit. Despite these challenges, Spirit methodically worked its way up the hill over several months, navigating obstacles and sending back valuable data to Earth. During the climb, Spirit made extensive use of its arsenal of scientific tools. The rock abrasion tool allowed Spirit to grind through the outer layer of Martian rocks, exposing pristine interiors for detailed study. The microscopic imager provided close-up views of rock textures, revealing important clues about their formation. Spirit's alpha particle X-ray, spectrometer, and Mersbauer spectrometer further analyzed the chemical composition of rocks and soils. Together, these tools uncovered evidence that the Columbia Hills region had experienced diverse geological processes, including volcanic activity and interaction with water. Among the most significant discoveries was the presence of rocks rich in sulfates, which strongly suggested that liquid water once flowed in the area. As Spirit climbed higher, technical issues began to arise. A minor short circuit was detected in its wheel motor, although engineers on Earth found ways to work around the problem. The rugged terrain also placed considerable strain on the rover's 6 wheels, slowing its pace but not halting its progress. Dust accumulation on the solar panels presented another major challenge. The fine Martian dust reduced Spirit's energy intake, at times forcing it into energy-conserving modes where scientific operations were minimized. However, occasional gusts of Martian wind cleared enough dust from the panels to keep the rover operational. These unplanned cleaning events became vital in extending Spirit's mission life and enabling it to complete the climb. Despite the hardships, Spirit ultimately reached the summit of Husband Hill in August 2005, nearly 600 sols after starting the climb. From this vantage point, the rover captured breathtaking panoramic images of the surrounding landscape. These images provided critical insights into the geology of the Columbia Hills and the broader Gusev crater, helping scientists piece together a more complete picture of Mars's dynamic history. Climbing Husband Hill was more than just a technical achievement. It symbolized the resilience of the Spirit mission and its ability to adapt to Mars's harsh and unpredictable conditions. It solidified the rover's role in transforming our understanding of the Red Planet, and it was on to find more. Discoveries on Cumberland Ridge. Spirit's exploration of Cumberland Ridge turned out to be a treasure trove of discoveries, showcasing the intricate history of Mars's geology and its potential for past habitability. 2 rocks, nicknamed Peace and Alligator, were at the center of this scientific chapter. These formations underwent meticulous analysis using Spirit's tools, including the rock abrasion tool, mini thermal emission spectrometer, and the Mersbauer spectrometer. Peace, in particular, revealed a significant presence of magnesium sulfate, a mineral often associated with long-term interactions between rocks and liquid water. This discovery reinforced earlier findings, suggesting that water had been a pervasive force on Mars, reshaping its surface and potentially influencing its ability to sustain life. The aptly named Alligator Rock featured distinct, jagged textures that hinted at erosion processes linked to ancient water activity. By examining these features, Spirit's team gained deeper insights into the forces that had shaped the planet's geology billions of years ago. These findings were not isolated. They painted a picture of Mars as a dynamic world where liquid water likely existed, possibly in significant quantities during its early history. While studying the ridge, Spirit occasionally directed its camera skyward. The rover captured awe-inspiring images of Phobos, one of Mars's 2 moons. The observations of Phobos not only demonstrated Spirit's versatility, but also contributed to understanding the enigmatic moon's surface and orbital behavior. The irregularly shaped satellite is thought to be a captured asteroid or a fragment of Mars itself. Spirit's images revealed surface features that provided context for ongoing studies about its composition and origin. Although a side aspect of the mission, these celestial observations were vital for unraveling Mars's broader astronomical story. One of the most surprising and significant findings of Spirit's journey across Cumberland Ridge came by accident. As the rover's wheels churned through the soil near a site later named Paso Robles, they exposed an unexpected deposit of bright, salt-rich material beneath the surface. Scientists quickly realized this white powdery substance was a mix of sulfates and other soluble salts, indicating the presence of highly saline, water-based environments in Mars's past. Such deposits are typically formed when water evaporates, leaving behind concentrated minerals, strong evidence that Mars once hosted environments capable of supporting life, at least in microbial forms. The Paso Robles discovery was groundbreaking not only for its scientific implications, but also for what it hinted about Mars's climate. Salty environments on Earth, like salt flats or hypersaline lakes, can be teeming with microbial life. Finding similar conditions on Mars opened the possibility that the planet might have hosted comparable ecosystems, albeit billions of years ago. These findings on Cumberland Ridge marked a turning point in Spirit's mission. Each discovery brought humanity closer to understanding Mars's history and its potential for life. The interplay of detailed rock analysis, panoramic images of Mars's moons, and the serendipitous discovery of salt-rich deposits underscored the critical importance of robotic exploration in unlocking Mars's many secrets. But the climb wasn't over yet. Reaching the summit. Reaching the summit of Husband Hill was one of Spirit's most challenging and rewarding achievements. The journey to the peak pushed the rover's capabilities to the limit, as it had to navigate steep slopes, rugged terrain, and the ever-present challenges posed by Mars's harsh environment. The climb, which took nearly a year, was a test of perseverance and ingenuity for both the rover and its team on Earth. Throughout its ascent, Spirit faced various obstacles, including slipping wheels, navigation issues, and the accumulation of dust on its solar panels, which threatened to reduce its energy efficiency. However, an unexpected ally emerged to aid the mission Mars itself. Dust devils, common weather phenomena on the Martian surface, swept across Spirit's panels multiple times, clearing off layers of fine dust. These natural cleaning events significantly boosted the rover's power output, enabling it to continue its uphill journey. Without these timely interventions, Spirit's mission might have ended long before reaching the summit. As Spirit climbed, it paused frequently to examine the geological features along the way. The rover collected a variety of samples, including rocks and soil, which revealed critical information about Mars' past. For example, Spirit discovered basaltic rocks that suggested the region had once been shaped by volcanic activity. Other samples contained evidence of water-altered minerals, which hinted at prolonged periods of wet conditions. These findings not only advanced the understanding of Husband Hill, but also enriched the broader narrative of Mars's history as a dynamic, potentially habitable world. Finally, in August 2005, Spirit reached the summit of Husband Hill, standing as a symbol of the rover's endurance and the ingenuity of its mission planners. From this vantage point, Spirit captured breathtaking panoramic views of the surrounding landscape, offering a unique perspective on the rugged terrain it had traversed. The images included sweeping vistas of nearby valleys, distant hills, and features such as Gusev Crater and the volcanic plains that stretched to the horizon. These panoramas served a dual purpose. Scientifically, they helped researchers plan Spirit's subsequent routes and identify areas of interest for further exploration, so other rovers won't have to go through what this one did. The way up was one thing. There was a lot more to come on the way down here. Descent and new discoveries. As Spirit made its way across the Martian terrain following its summit victory, the rover's mission continued to uncover groundbreaking findings. The next phase of Spirit's journey marked a renewed collaboration with other scientific instruments beyond Mars itself. Notably, Spirit teamed up with the Hubble Space Telescope, using its unique position in space to observe Mars's atmosphere and surface at a different scale and provide additional context to Spirit's localized explorations. This collaboration enhanced the rover's analysis of Martian geology, as Hubble's observations could detect large-scale atmospheric patterns, helping to better interpret the specific areas Spirit was studying on the ground. Despite ongoing challenges such as dust storms and technical malfunctions, Spirit was not alone in its pursuit of scientific discovery. Over the course of its mission, various upgrades were made to improve the rover's performance, particularly as it began its descent from the peak of Husband Hill. Notable updates to Spirit's software allowed it to operate with increasing autonomy during the descent. These improvements allowed the rover to conduct more efficient and independent operations, which ultimately maximized its productivity on the Martian surface. With every adjustment, Spirit became more adept at maneuvering over rough terrain, selecting key targets, and executing scientific experiments without direct command from mission control. This level of autonomy added both efficiency and flexibility to the rover's capabilities, which helped drive new insights into Mars's geological history. One of the key areas Spirit explored after its descent was an intriguing rock formation, which scientists named Comanche. The analysis of Comanche's mineral composition led to one of Spirit's most important discoveries. The rover's instruments detected the presence of magnesium iron carbonates compounds that are considered key indicators of past water activity. These minerals form only under specific conditions, particularly in the presence of liquid water over long periods of time, meaning their discovery on Mars was groundbreaking. This finding was pivotal in supporting the theory that Mars once had the necessary conditions for microbial life, or at the very least, liquid water long enough to create these minerals. The discovery added to the growing body of evidence that suggests Mars was once more hospitable than it is today. Spirit's work in analyzing Comanche was instrumental in helping planetary scientists understand how Mars's climate and geochemical conditions might have evolved over billions of years, ultimately shaping the surface seen today. Throughout the descent and the continued exploration, Spirit showed the immense value of long-term scientific investigation. The combination of improved autonomy, collaborations like that with the Hubble Space Telescope, and unexpected discoveries like the magnesium iron carbonates enabled Spirit's team to push forward the limits of space exploration, including what was coming next: exploration of home plate. After Spirit's success at the summit of Husband Hill, the rover continued its exploration of the Martian surface, eventually heading toward a region known as home plate. This site, located within the Gusev crater, quickly became a focal point for the rover's scientific endeavors due to its intriguing geological features, which suggested that water had once been a major force shaping the landscape. Home plate is a large, flat, geologically unique area with layers of rock and mineral formations that were indicative of past water activity. As Spirit examined the area, it began to uncover rock formations that had been shaped by processes involving liquid water, such as the formation of evaporite deposits and the presence of sulfates. These findings further supported the theory that Mars, in its distant past, might have had conditions conducive to liquid water, a vital component for life as we understand it. Scientists marveled at how well preserved the features at home plate were, allowing for detailed analysis and a deeper understanding of the planet's early environmental conditions. The geological history that Spirit revealed through home plate was one of the key moments that helped change the narrative about Mars's potential to have once harbored life. However, the mission was not without its setbacks. Spirit experienced a series of technical difficulties, with one of its wheels failing. The rover had to be navigated carefully due to the damage, and its mobility was severely restricted. The challenge became even more pressing as the Martian winter approached, and the rover's solar panels needed maximum exposure to sunlight in order to function. With the damage to its wheel and mobility limitations, Spirit's team had to work meticulously to chart a course that would help the rover survive the harsh winter conditions. This led to Spirit's relocation to a site called Low Ridge Haven, where the rover could settle for the winter. Low Ridge Haven was strategically chosen because it offered an optimal tilt that allowed for better sunlight exposure to Spirit's solar panels. Despite the rover's technical difficulties, this location helped mitigate the harsh winter conditions and provided Spirit with enough power to continue its observations and work. During the winter, Spirit remained operational, albeit with reduced mobility and a more limited scope of scientific objectives. It continued to make valuable observations from Low Ridge Haven, including potential iron meteorite discoveries. Spirit's cameras captured images of rocks with a distinctive metallic sheen, leading scientists to speculate about the presence of iron meteorites on the Martian surface. This finding would further enhance our understanding of Mars' history and the possibility of meteorite impacts shaping the planet's surface over time. Though Spirit's mobility was restricted during the colder months, the rover's continued operations provided invaluable data on Martian geology, water history, and potential extraterrestrial objects, solidifying its place as one of the most successful and enduring missions in the history of space exploration. But not all of the discoveries were on purpose with this rover. Silica Discovery Spirit's exploration of Mars led to one of its most significant discoveries, the exposure of silica deposits, an event sparked by the rover's damaged wheel. As Spirit navigated rough Martian terrain, its failing wheel inadvertently caused the rover to scrape away parts of the surface that were otherwise untouched. This exposed buried layers rich in silica, a mineral known to form in hot, aqueous environments, such as those found around hydrothermal vents on Earth. These vents are often full of microbial life, thriving in the extreme conditions of heat and mineral-rich water. The discovery of silica deposits was monumental for several reasons. Silica, on Earth, is strongly associated with hydrothermal systems that support microbial life. Its presence on Mars raised intriguing possibilities about past environments where life could have once existed. Scientists had long speculated that Mars might have had conditions that could have supported life at one point in its history, particularly in areas with hot springs or hydrothermal systems. The silica deposits became a key piece of evidence, reinforcing the hypothesis that such environments might have existed on ancient Mars. This finding suggested that if Mars ever had hydrothermal systems, they could have been viable locations for life to develop. Silica, when formed in such conditions, could preserve the evidence of microbial life, much like it does in Earth's hydrothermal environments. The minerals trapped within these deposits could potentially reveal insights into the chemistry of ancient Martian life forms, assuming they existed. Spirit's analysis of the silica samples helped to refine models of early Martian environments. If these deposits were formed in the presence of liquid water, it suggested that Mars may have once had both the necessary ingredients for life, liquid water, and the right chemical elements, and a stable environment capable of supporting biological activity. This unexpected exposure of silica not only revealed an exciting find for scientists, but also demonstrated the enduring adaptability and contribution of the Spirit rover, even when faced with seemingly insurmountable challenges. Extended mission and final days. After an unexpected cleaning event in 2009, Spirit's mission was extended, allowing it to continue its work on Mars for several months beyond the original mission timeframe. The cleaning, caused by a dust devil sweeping across the rover's solar panels, significantly increased its power generation, giving Spirit the necessary energy to keep functioning and sending back valuable data. This boost in energy gave NASA a chance to squeeze more science out of Spirit, even though the rover had already exceeded its expected lifespan by several years. This new breath of life was critical, as Spirit had faced numerous challenges, including a failed wheel and the harsh Martian terrain, but it was clear that this rover wasn't quite done yet. As Spirit's extended mission continued, it made one of the most important discoveries of its journey near the site known as Home Plate. Spirit spent a great deal of time exploring this plateau-like region, which exhibited signs of having been shaped by the forces of water. The rover uncovered layers of rock and soil that displayed features indicating past aqueous activity, further supporting theories that water once flowed on the Martian surface. Spirit's observations around Home Plate offered invaluable insights into the Martian past, helping scientists refine their understanding of the planet's early environment. It was an area rich in geological history, offering key clues about Mars's potential for sustaining life in its distant past. With Spirit now on its extended mission, a detailed exploration strategy was implemented, focusing on key regions of scientific interest, including the examination of distinctive rock formations and mineral deposits. This shift to more targeted exploration was made possible by Spirit's sustained ability to stay operational, even when faced with technical issues like the failing wheel that made movement across the terrain a challenge. Despite these setbacks, Spirit's maneuverability, especially after cleaning events or adjustments to its programming, allowed it to continue its journey and find details about Mars we otherwise couldn't possibly know. Ferric sulfates, indicating water movement. One of the most groundbreaking discoveries made by Spirit on Mars was the identification of ferric sulfates in soil samples, a key finding that indicated the movement of water through the Martian surface. As Spirit analyzed various soil samples, it detected the presence of these sulfates, which form when sulfuric acid reacts with iron-rich minerals. What made this discovery so significant was not just the presence of these compounds, but the evidence that modern water was actively transporting these minerals downward through the soil column. The discovery provided an exciting glimpse into ongoing geological processes on Mars. The fact that the ferric sulfates appeared to have been moved or redistributed by liquid water suggests that even in the present day, water may still be interacting with the Martian surface in a limited but dynamic way. This finding shifted our understanding of the planet's past and present conditions, further bolstering the argument that Mars had, and might still have, water systems capable of altering its soil and mineral composition. The detection of ferric sulfates gave scientists a clearer picture of Mars's geology, as the minerals were consistent with regions of the planet that experienced acidic water. It raised important questions about the role that water has played in Mars's past and its potential for sustaining life, particularly in subsurface environments. This discovery of ongoing water-driven processes laid the groundwork for future missions aimed at understanding Mars' water history in greater depth. This also means that Mars as a planet is still undergoing geological changes, with the potential for liquid water, or its remnants, playing a more significant role than initially anticipated. This reinforced the notion that Mars, despite its arid surface, had complex processes still shaping its environment today. It brought new information about the places that we'd only learned about on the surface before. Complex rock coatings from modern water. One of Spirit's most compelling discoveries was the observation of complex coatings on olivine basalts in Gusev crater. These coatings were unlike anything previously seen on Mars, suggesting that modern water, or possibly frost, had been actively altering the rock surfaces. The presence of these coatings provided solid evidence that water, far from being a thing of the distant past, continues to shape the Martian landscape in the present day. Olivine basalts are a type of volcanic rock, and the coatings observed by Spirit indicated that they had undergone some form of chemical alteration, likely caused by interactions with liquid water or ice. These alterations seem to occur recently in geological terms, possibly within the last few million years. This was significant because it confirmed that water was not just a historical feature of Mars, but that it could still play an important role in shaping the planet's surface. The discovery was exciting because it suggested that Mars might still have ongoing hydrological processes, despite its current arid conditions. The coatings hinted at a more active and complex environment, one where water might occasionally seep into the ground or frost could form and undergo cycles of melting and refreezing. This might point to potential underground reservoirs of water or seasonal frost, altering the surface in localized ways. For scientists, this finding was crucial as it helped deepen the understanding of Mars's geological activity. The fact that modern water or frost was still at work on the Martian surface supported the theory that Mars could be geologically active, with liquid or frozen water influencing the landscape. This discovery further fueled interest in the potential for life on Mars, suggesting that even in the modern era, conditions conducive to microbial life might persist in sheltered areas or below the surface. But all good things must come to an end. In its final months, Spirit became somewhat of an ambassador for NASA's perseverance and dedication to exploration. Even though it was operating far beyond its expected lifespan, Spirit continued to send valuable data back to Earth. Launched in 2003 with a mission duration of 90 days, Spirit far outlived these expectations, operating for nearly 6 years before encountering mechanical difficulties. Yet, Spirit's role wasn't just about its initial goals. It evolved into a symbol of humanity's determination to overcome adversity and keep pushing the boundaries of exploration. Despite its deteriorating condition, Spirit's systems were pushed to the limits, extracting data that would provide insight into Mars's geology, past conditions, and the potential for life. The rover's commitment to scientific discovery became emblematic of NASA's resolve and its broader goal to answer questions about Mars. Even as Spirit struggled with movement and other operational failures, the rover still had an incredibly valuable role to play in NASA's research. With engineers working relentlessly to address the challenges caused by the wear and tear of the harsh Martian environment, the team adjusted their strategies to ensure Spirit could continue its mission. The rover's solar panels, though dust-covered and sometimes degraded, were cleaned by occasional dust devils, giving Spirit temporary boosts in power and allowing it to maintain crucial functions for extended periods. As Spirit slowly inched its way toward home plate, the rover's final location of importance, scientists maximized its capabilities to extract geological data. Near home plate, a unique feature on the floor of Gusev crater, Spirit encountered a variety of rocks, including unusual mineral formations never before seen in earlier rover missions. These findings helped corroborate the idea that Mars had experienced more complex environmental conditions in its distant past. Spirit's analysis of mineral deposits such as sulfur and silica, as well as new measurements of Martian soil composition, helped researchers conclude that Mars might have hosted liquid water for extended periods. Spirit's findings did more than answer long-standing scientific questions. They set the foundation for future missions exploring Mars in even more detailed ways. The legacy of Spirit, alongside its sister rover Opportunity, gave NASA a wealth of data to inform their planning for upcoming missions. These results prepared the groundwork for NASA's subsequent rovers, like Curiosity and Perseverance, both of which would build on Spirit's trailblazing work by delving deeper into Martian geology, especially in the hunt for signs of ancient life. The rover's final days were quiet, gradually slipping into inactivity due to its fading battery power and the relentless Martian dust storms. Spirit sent its last communication to NASA in May 2010, marking the end of a historic mission that had provided countless findings. The rover, however, left a legacy far greater than its final hours. Spirit's discoveries on Mars, paired with the efforts of the engineers and scientists who worked tirelessly to keep it active, turned it into one of the most successful space exploration missions ever. Even after years of silence, the data it gathered continues to influence space missions and the quest to answer key questions about Mars, ultimately supporting future plans for human exploration of the Red Planet. That is, if we can create something determined enough to really follow into Spirit's footsteps. What do you think? Leave your thoughts in the comments below, and if you liked this video, don't forget to subscribe to our channel. See you in the next one.